So if we could, we can measure one and then see how tall that one is, and then measure the other and see how tall that one is, and then you can tell which one is taller.
Yeah. What I did, I was thinking since we have pencils, we can measure it with the pencils and round it. See, like right here, through the part right here to the foot, and then we can measure it to about right here, and then we can do the same for this other giraffe, Geoff. And it's the other giraffe is like a tiny little bit taller. See, looks like
What I noticed is that there were lines that you could see, so you could count how many pieces there were on both of them, then see.
yeah.
It's insane because you can just go like this, and you can see that they're the exact same.
But what if you count these lines? What if it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Wait, no, that's a good idea. Hold on.
4, 5, 6.
1, 2, 4, 5, 6.
So it could be 6 inches.
4, 5, 6.
Or 6 feet, I mean.
Yeah, but that doesn't, I don't think that really matters because this line right here is going all the way across.
Well, and that could be because this is way smaller, and then this one's way up here, and this one's way down here. So if they were lined up, then
That would actually change their height.
well, but it would look at it in the closest perspective. Look, if we put it up, it could be the same height or even taller.
Well, the first line on Geoff is all the way down on his feet. The first line on George is like all the way at his ankles.
Yeah, that's true. But maybe they're just trying to show like that this is the same as that, but this one's taller. Like they're just making that smaller to say that he's taller. Haley's the same size.
Well, you can't see their body really.
Like look, but like when you go like this, Haley looks the same size. But and then it says, is the size of the image you can see affected by far away? So if you look more far away. So like if I was looking at your face is like this big. Well, you're right, like
She looks way smaller from there.
no, like you're right because like different scopes. So you have a bigger scope, you can see farther and you can see like the image bigger. And then when you have a smaller scope, you can see the image smaller. So it does affect the size because if you want to have like a bigger image, then you need a bigger scope. But if you want a smaller image, you need a smaller scope. And then it says, how does the distance from an object compare to the height of the image? So if something was more far away, then the scope would probably be smaller, or the height.
So can we please listen to everybody's ideas, please?
After sharing our thoughts, we thought George was taller because Geoff appears taller because of the tree. The tree Geoff was standing by is smaller than the tree George was standing by. If you look hard enough, you will see the difference of size between the trees. With all this evidence and thinking, George is almost at the top of the taller tree, and there was our answer.
Okay, so they have, that
It looks small if you lean forward.
I'll sell it to like a 7th grade student.
Okay, select a scope of particular size.
Like a clear focus, like kind of.
like when I was doing like this, I could kind of see like the full like better. But it's still being small because the scope size.
So you kept the diameter the same
Yeah.
and changed the distance?
Yeah.
We were just gonna like subtract the length of the scope from the 60 feet. So yeah, that's all we have so far.
But it's closer up. Like it's not. You just see a.
It doesn't.
It makes you. But it makes you think because you see a specific part of it.
You only see that image. That just it makes you. It doesn't make it bigger. It just makes you focus in on it more.
So it doesn't affect it, but it changes how you view it.
Yeah.
Should we measure it out? Because this is taken from 60 feet away. So this is the picture. So when we do the same thing that happened last time. Well, the farther away you get, the more of the image you get.
Yeah, so the closer you get, obviously, the less. Talk. I want you to talk with your partner about level C and how you could do it.
Hi.
Size. So we'll choose that scope for the starting basis. So you can measure its radius here. Make it all tight now.
Can we just make it flat like this?
No, that won't work as well.
What do you think will happen if you make it tight?
It will be a little easier to measure, and it will be smaller. Maybe.
From the object, the height.
The farther you are from the object, the more of the object you get. But when the scope is wider, it's not more about how much of the object you get, it's more of the surroundings.
Yeah. It's like,
I think so. But are we supposed to find the height of the ticket?
I don't think so. It doesn't say finite, so. So I think we should just write the distance, the relationship is the farther you are from the object, the more the object you can see.
Yeah.
You were switching feet to inches? Yeah. And how is that going to help you?
I was thinking like if the tube is like 2 inches tall and you're 6 feet away, then multiply the distance by the height of the tube. Maybe that would be.
Let's just pretend.
With the pencil, made a mark in the pencil. So Jerry's 3 times.
I measured them with my finger.
Okay, so that will be.
The tree is smaller. It's still right though. It's good. I was looking at the tree, and the tree, Geoff is taller than the tree, and then
But are the
George
trees the
is
same size?
I'm assuming so.
But you didn't measure it.
Well, it's still, Geoff is still taller. I measured it as well. and he's still
Okay, yeah. See, I measured the giraffes and then went by how
And then I
tall
said
each one was.
taller. Jerry is 3 Jerrys equal 1 George.
Really?
Yeah.
I said that 2 8/9 of Jerry equals George.
Really?
He's like a tiny bit. He's a little less than 3.
Is that
Because I measured with my paper. Let's see if I still have it written down.
about an inch and a half? So he's about an inch and a half. So there's 1, 2 Georges. It's
Are you sure it's a half? Okay, so like there's George's full length.
no, Gary is about. I mean, 2 Garys and a half.
George.
I think about measuring it like that.
What?
I think about measuring it like that.
I guess it's technically 30. But for being exact, it's a little less.
Okay, we're also like 2 points.
Right?
Okay, well look at your measurements.
I did.
Yeah, he's like exactly 3.
But no, it cuts off the top of his little antlers.
Okay.
A little bit, like
A little
the
bit.
tiniest bit on Earth. Okay, next problem.
Can be larger, like
It's already big.
meaning the same height repeated 12 times, and that would be
Yeah, so I said I would cover the poster because in the picture it's already like covering it, so maybe it would be on a bigger poster. It's going to be 12 times larger, so that's what I said.
What'd you get for 2?
well, since it mentioned earlier about being 12 times larger, I thought that it would just, I don't know, I divided 32 by 12. But I think I did it wrong.
I did 32 minus 12, and I got 20 inches because if it's 32 inches tall on another poster, and then it says that like when it's chopped, it gets larger. So subtracted by 12.
If it's 12 times taller than.
Anyways. So, what are we on this one?
Yeah. Go ahead.
So I did like a little like diagram thingy majigger.
I did a diagram too, but mine's on the other page.
Little diagram. So like A, this is A. The shorter the tube, the closer it seems, and the wider the tube, the taller it seems. The taller it seems.
And the farther away it seems like the longer.
The longer tube seems like it's farther away. That's why like B is all the way out there and C is like really close.
Yeah. I said that the giraffe would be like the giraffe would be however tall your scope is by how far away you are. So